Hello there and welcome. In this lesson, we're going to learn about access modifiers in C#. Access modifiers are a part of encapsulation, one of the four pillars of object-oriented programming. So we talked about these four pillars, but I never explained what each one of them meant because I did not want to overcomplicate you. So in this lesson, we're going to learn about one of these pillars, encapsulation. Encapsulation helps us control how we can access or modify data. This prevents unwanted changes to the data and improves security. It creates a better structure to the code and keeps everything organized. And the way we can control who can access the data is by using access modifiers. Access modifiers are just keywords that we can couple with a class, a method, or a variable, and this way we can assign this protection level or this access level for the data. There are several access modifiers in C#. Some of them are common and we use them all of the time. Other ones are very specific and you may never even encounter them. So the main ones are the public access modifier and the private access modifier. And there's a reason I'm not showing you the rest right now, because these are the two main ones you need to understand encapsulation. We use these keywords each time we want to either enable access or prevent access into the data. Public means that everyone can access the data. Private means that only data can only be accessed inside the class. So when we say private, we say that it's private to the class itself. If we go to our car class that we created in one of the lessons, we can already see these access modifiers over here. So we can see that these variables, these fields have them, and also the methods themselves have these access modifiers. And at this point, all of them are public. And it means that we can access all of them, because public means that everyone can access the data. So for example, if we create a car class, and I want to get some kind of data from this class, from this object, then I can simply use the name of the variable or the method, for example, max speed, and this will be available. So I can basically change the data. I can set a different value to this data. It will change the data that is inside of this variable. But I can also use it to print the data. For example, I can use console log and print the data. So it will print the max speed. I can set data and I can get data because this max speed is public. I can also use these methods because these methods are public. So I can say my car drive. And this will basically call this method. And the same way with these variables and any other member that we can have inside of the class. Also this owner, which is a class, it is still a member of this other class, and we are going to be able to reference it because it's public. Now with private, we can make these members or these data types inaccessible from the outside. So for example, if we have something that we don't want to allow to change, max speed, maybe we do want to allow to change, although it doesn't really make sense to change the max speed, right? If we had speed over here, then it makes sense to change the speed. Maybe the car starts to accelerate, and then we increase the speed. We do something like this, or maybe we do something like this. We increase the speed. But there is no point of changing the max speed because the max speed is a part of this car, right? Each car has its own max speed, and usually when we build this car in the factory, it will always have the same max speed. So in this case, we can make this private because we will never actually want to change the value. And we also don't really want to get this value because this value should only be used inside of the class. Now you can see that because we changed it to private, it now tells us max speed is inaccessible due to its protection level. And it means that it's private. We cannot use it. It will not print it. And if we delete this, then we won't even see it over here. Max speed, we won't even see it over here because it's private. And as I told you, private means that it can only be accessed inside of the car class. And with max speed, it makes sense because we don't want to change the max speed. We never want to change the max speed, but we may want to use it, maybe reference it inside of the class itself. For example, when we drive, maybe we can check if speed is bigger than max speed, then we can maybe limit the speed because we don't want the speed to go over. So some variables are used only inside of the class, and this can be variables. We can also have private methods. Some methods should be used only inside of the class, and there is no reason for them to be public and available outside of the class. And it really depends on the functionality. As I told you, with the car, we may have a max speed, but there is no reason to use max speed outside of the car. We don't want to change the max speed. It doesn't make any sense. But inside of the car class, we do want to use it. We want to get the value. Maybe we want to do other things with it. Also, methods. The drive method can be used outside of the class, but maybe we have another method, maybe private void limit speed. And over here, we do some kind of logic that will limit the speed. So we're going to call this method from within the class itself. So if the speed is bigger than the max speed, we're going to do some kind of logic that will prevent the speed from going even higher. So we're going to limit the speed, and this method is a part of the class and it's private because there is no need to use this limit speed outside. We can't even see this limit speed over here. There is no reason to limit the speed outside of the car class. And how do we know if it should be private or public? Because of the functionality. If there is no need for this to be accessible from the outside, from a different class or just outside of the object, then we're going to keep it private. If we need to access it, then we're going to make it public. So a small suggestion would be to always start with private, make everything private, and only when you actually know that you need to use something and there is a good reason to use it, for example, increasing the speed, then you can make it public and it will be accessible. Now, obviously, a better way to increase the speed is still inside of the car class. Maybe when we drive, we can have some kind of method, private void increase speed, and it will take the speed and increase it by 1. So when we drive, we are going to limit the speed, and we're also going to call increase speed, and we're going to increase the speed. So I hope you're not too overwhelmed with this because we still did not cover methods, but by now I probably assume you understand what it does. We call this method, let's say over here, and then it's going to basically go into this block of code and it will run this code. So this is a simple explanation of what a method is. Obviously, there are a lot of things to methods, and we're going to talk about this when we actually have the lesson about methods. But just understand that methods can be private because there is no need to use them outside of the class. We want to use them inside of the class, and it all depends on the actual functionality, on the actual logic. We do want to make the drive method public, right? Because we do want to be able to start driving the car somewhere else. We don't want to start driving inside of the object. We should be able to use this method publicly, and that's why we make it public. But to increase the speed, there is no need to increase the speed here because we are increasing the speed automatically using this method, and this method is private. Now, if we don't want to change the speed only using this method, then it should also stay private because we don't want to modify the speed manually. We want it to only change inside of this method. So also this should stay private. What else? Maybe the name should also stay private because it comes when we create the car. So it's really about understanding your classes, your objects, and we're going to have more examples later on of different classes and different variables in these classes. So little by little, you're going to understand when should something be private and when public. But the main idea is that with public, everyone can access it, and with private, only the class itself can access the data. Now also don't get confused because some get confused with this. When we talk about access and when we talk about security, we're not talking about human access, right? Because this is your code. You have access to these classes. You can change them. It will not prevent other people from changing the code. It will simply prevent the code from accessing this data. And this is important so we don't make mistakes, so we don't break the code, so we don't have bugs. Imagine you have a very long code and then a new developer joins the company and he starts working on this class. Now, it's not about protecting the data from this person. It's about organizing the code so things won't be modified if they don't have to. Because if you had this class, this car class, and you created this class, and then there's a new developer in the company, and his job is to create another class, maybe a Pokemon class. And maybe this Pokemon should be able to drive a car, but you don't want to allow to change all of these things. So he will be able to use your car class. He will be able to create a new class, but you don't want to allow to do different things, and you basically want to explain how this class is working. So although these access modifiers are important to control access, they're also kind of descriptive, right? They explain what is the purpose of this variable. When we see that something is private, we can know that it will not be used outside of the class and that it's probably only used inside of the class. Also, we can know that it's something that should not be modified unless we modify it inside of the class by using special methods. Maybe we want to do something else before we increase it. Maybe we also want to update. Maybe we want to update the speed gauge, right? When we increase it, actually it makes more sense to increase the speed and only then to update the speed gauge. Maybe we always want to update the speed gauge when the speed is changing, and all of this will happen together in the same method. So we don't want to allow to change the speed in a different place, otherwise we may forget to update the speed gauge. But by adding them into the same method and always using them together, we will make sure that when the speed increases, the speed gauge will also be updated. So it's all about preventing bugs. It's all about organizing our code so everything will work as it should and we won't make mistakes. So access modifiers are about organizing our code and not really about securing the code as you would think we secure Wi-Fi access or something like that. So don't get confused. So these are the two main access modifiers that we always use. And we're going to talk about a few other ones, but they're actually quite rare. For example, we have the protected. And protected will allow access to the class only to children of the class. So when I say children, I talk about inheritance. And again, this is a long word, one of the 4 pillars of object-oriented programming. We're going to learn about inheritance later on, but inheritance is the option to create a class that basically inherits from a different class, and by this it becomes a child class. So a very simple example, again, I don't want to overcomplicate you, but I just want you to understand what protected is. We can have a class vehicle, and although we usually create these classes in a separate file, we can also create them inside this file. So we can have a class vehicle, and this class will have a protected string password. Now, we can create another class, let's say the car class, although we already have a car class, so maybe a bus class, and this bus class will inherit from vehicle. So it's like a child of the vehicle class, and it basically means that the vehicle class is the base of this class. And it also means that the bus class can use the different members that are inside the vehicle class. Again, I don't want to overcomplicate you. We're going to talk about this in a separate lesson. But now that bus is inheriting from vehicle, we can have a method that will be able to access this password. And we know that if we use private, we cannot access the variable outside of the class. But if we do need to access it, and we also want to make it private, so it will be private to the class, but also be accessible by children of the class, then we use protected. So I think it gives me an error because, yes, public void, and then we try to access this password. We won't be able to access this password, although it should be accessible, right? If we make it public, we will be able to access this password, and it may be confusing because you don't see this password inside this class, but because it's inheriting from the vehicle class, it has access to all the different members inside of the vehicle class as well. Imagine this is a blueprint for a general vehicle, but a bus is a very specific vehicle, and the vehicle class will only contain logic that is very general to vehicles, but the bus class will contain data that is specific to buses. But it will still be able to access these. Now, if we don't want to make it public, otherwise other classes can also access the password. We only want to allow the bus to be able to access this. So for this, we can use protected, because if we use private, this will not be available. But if we use protected, then this will be available, and then we can maybe print the password. And do things with it. So always remember, protected is more related to inheritance. So I hope that I did not confuse you too much. I usually try to avoid adding more advanced knowledge into these lessons, but it was necessary to understand what is protected, and if you actually understood it, then it means you have good potential. Now, another access modifier that we have is internal. Now, internal can be a bit more tricky to understand, but it basically means that the data can only be accessed from within the same project. Now, you may be confused because you may ask, well, all the code is in the same project. How can we even access code from a different project? But that's totally possible. When you're working on some kind of big platform, then you are going to be able to access code from different projects. And it's very common when we use libraries. Again, I don't want to confuse you, but libraries are basically packages of code that are provided by others, and we can use them to use specific methods or specific logic, especially if we don't want to write all of this code by ourselves. Maybe we want some kind of AI logic, so we don't want to start writing it from scratch. We want to use some kind of package that provides us this AI logic. And this package can also be called a library, and we can use different libraries inside of our projects. So when we use internal, we basically say this code can only be accessed from within the same project, but if another project will try to access it, for example, if this car will be a part of a library and then some person will download this library and try to access it, he won't be able to access variables that are internal. It can be a bit tricky to explain it here because everything is inside the same project, but just know that when you see internal, it means that it can be accessed from the same project. So it's basically public for the entire project, but if you will try to access it from other projects, then you won't be able. So it's especially relevant when you are working with multiple projects. There are two more rather rare access modifiers, which are protected, internal, and private protected. So these can be easily understood by understanding these access modifiers. Protected internal basically means that it can only be accessed inside the same project, right? Because it has this internal access modifier, but it can also only be accessed from a child, exactly like this protected. So think about this as a combination of both of them. Private protected is a combination of private and protected, so you are going to be able to access it from a child, but not from a child in a different project. So again, it can start to get a bit more confusing because we're talking about projects and classes, but this is the most restricted access. We can only allow for children to access it only inside the same project, because with protected, all children can access it even from different projects. So with protected, children can access the class. For example, a bus can access data inside the vehicle class, but it can also happen from a different project. If this class is in this project and we create a child in a different project, it will be able to access it. With private protected, this won't be available. We can only access parent classes, but only in the same project. So these are all the access modifiers, and again, these ones are less used. They're used in specific situations when we are working with other projects, when we are working with inheritance. These two are the ones that you're mostly going to use. I don't remember if I mentioned, but if you go to some class and you see that some of the variables or methods don't have an access modifier, it simply means that they are private. So if you don't see an access modifier, it doesn't mean that they don't have access modifiers. It means that it's private. So it's not public, it's private, and you will have to make them public, or you can keep them like this. So it doesn't matter if we write private or we don't write anything, it's exactly the same thing, and this won't be accessible from the outside. Now, other than access modifiers, encapsulation can be implemented with other things like getters and setters. Getters and setters are just a secure way to get data and set data inside of classes. So exactly like with access modifiers that we can prevent access, with getters and setters, we can provide access, but we can control the access. So if someone tries to set a value, we can do some kind of check before he sets a value to make sure he sets a correct value. Also, when we try to get the data, we can do some kind of check to know that this data should actually be accessed. And a simple example is by creating some kind of person class. And inside we may have a private int age. So obviously we are not going to be able to access this from the outside because it's private, but then we may still want to allow to get this data. So for this, we can create these getters and setters. These getters and setters are going to be public because we do want to allow to use them outside. So we have set age, and get age. Now, this may not be the best time in the course to teach you this because it again has to do with methods, but it's still a part of encapsulation, so I do want to talk about this. When we want to get or set data to this age from the outside, we're simply going to use these methods. So if we want to set a value, imagine we have a different class outside, and we create this person. Yeah, it won't allow us because... Okay, so we want to access this person age. We won't be able to access it, right? Because it's private. But what if we do want to allow to, let's say, get this age? We can simply create this getAge method. So it's a getter. And inside we're going to return the age. So again, we start to dive into methods and about the value that we want to return. But just think about it as a way to control how we can get the data. And now instead of getting the age like this, because this is not possible, we can use getAge. And then we can basically do whatever we want. We can print it, because this is not going to work. We can print this by using getAge, and it's simply going to return this age that is private. With setters, we can set data, and we also need to use a parameter, although again, I don't want to overcomplicate you. We basically can create some kind of access if we want to change this value, right? Because we made it private. We cannot change the value from the outside. We cannot even access this. So how can we assign a value? We cannot access this. But if we do want to allow to change the value in a different way, we can create these setters, and then the person is going to use this instead. And he's going to provide 5 inside. And this 5 will basically be inserted into the method, and it will become the value of age. Now, what's good about setters and getters is that we can do more logic while we set the data. For example, we want to make sure that the age is not 0. So we have some kind of control. If new age is bigger than 0, then we're going to allow to change the age. We don't want to allow to change the age if it's smaller than 0. Else, we can give some kind of error. Then we can add more conditions. We can check or or maybe and new age is smaller than 100. Maybe it doesn't make any sense. Maybe the person by mistake wrote something large, so we want to make sure that it's bigger, it's smaller than 100. Then maybe we have another check. So we want to check that all of this is true, and only if all of this is true, we are going to allow this new age to become the value of this age. So we basically make the actual variable private, so it's not accessible from the outside world, but we create these specific methods that will allow to set and to get the values of these fields. And this is a very important part in encapsulation because it makes the code bug-free. Imagine you didn't have this and the person would simply imagine you keep everything public, and then another developer, or even you, maybe later on your code is very long and you forget where everything is at, then you will simply try to look for the age of the person and see, oh, look, there is the age, let's change the age. And you're going to set the age over here. But maybe you have another method that should also update the UI or something like this. And because you changed this over here, the UI was not updated, and then your users are going to complain that the UI is broken and it's not working, and that's just because you allowed to change the value like this instead of actually creating some kind of specific method that can maybe also update the UI. So you can make sure that each time we set the age, we also update the UI and we call this method, and this will prevent different bugs. It will keep the code organized from yourself, because don't think that you will remember all the code you wrote. You can have hundreds of different classes, and these classes can be 1,000 line long, and you will not remember all the code you wrote. So when you're going to try to do something, you're going to try everything. Oh, I need to do something with this person. I need to set the age. Oh, I do have access to age, so I will change the age. But this will create a bug. That's why we're going to make it private, and we're going to allow these setters and getters. And then if you come back after several months, okay, I need to change the age of this person. Let's see, I don't have the age variable, but I do have set age. Okay, so I need to provide it with something. Let's see, I need to provide it with the new age. The new age will be 56. And now it will go into this method and it will do all of these checks. So it will also make sure you did not add 0 by mistake, or did. This is useful with passwords. For example, you create a new password, or maybe you create a new user and then it will check you did not enter an empty name, or maybe you did not enter some swear words. So we can do a lot of different checks before we actually set the value. And then we can also do other code that should always happen when we set the age. For example, update the UI. So we can have control over the setting and the getting of this age. And that's the entire point of getters and setters, and basically the whole idea of encapsulation, right? Because access modifiers are a part of it as well. The last thing that we have in encapsulation is properties, but we're going to have a dedicated lesson about properties. And it's just a shorter way of creating getters and setters. Instead of having a separate get method and a separate setter method, we can create a property. And let me just give you a very simple example, although I don't want to confuse you. Again, we have this person class, we have this private int age, and we don't want to allow access like this, but we do want to allow to change it or to do different things still under our control. So we can create a public int age. So this will basically be served as the public version of this private age. And with this, we can create these getters and setters inside of this property. So this is a property, this thing over here. And now we can create a get inside, and we can also create a set inside. And now each time we're going to try to get this, we're not going to get this one, the private one, we're going to get this one, the public one. But when we get the public one, it's going to return the private one. Now again, we can add more code inside. Then when we set the value, we can do the same thing like we did before. If value is smaller than 0 and value is smaller than 100 or bigger than 100, no, we do want it to be bigger than 0 and smaller than 100 like before, then we're going to allow to set the value to this age. Otherwise, we're going to console log age must be above 0. So this is exactly like before, but instead of having two separate methods for getters and setters, we can add these getters and setters inside this property and do the same checks, the same validation, and this will basically set this private age. And the value is just a keyword for the value that we're going to provide from the outside. So then we can create a person and usually when we create a class like this, we should write the code above it because all of this is also a class. So if we have person, obviously we won't be able to access this age. You can see this lower a, but we are going to be able to access the bigger version, the public version, and we're going to be able to set values. So now we can set the data to this age, and it will basically go here to set, and it will take the value, and the value that we're trying to set is 69. So it will take the value and it will check if it's bigger than 0, if it's lesser than 100, and only then it will set the value to be age. And then age will become 69. So without actually giving access to this age, we did manage to set a value to this age by first doing some validation and checking that everything is alright. And if not, then it would give this, because if I try to set 0, it will give me this error. And also with get, you only see that I return the same value, so you may think that there is no point of doing this, but we can add more code. For example, maybe we need to decrease 2 from it before we return it. Maybe we need to turn it into a string or something like that. So we can do other code here before we actually return it over here. And of course, if we want to console, we can use the person age and we can print this like that, because it will basically get the age, which is the age. And that's it. That's the point of encapsulation. It's about accessing data. It's about making data private so it can only be accessed from within the class. So this helps us to keep the code much more organized, much cleaner, much more descriptive, so we know what should happen with every data type. Is it public? Is it private? And that's the beauty of encapsulation in object-oriented programming. So that's all for this lesson. Thank you for watching. If you're still not a subscriber, you can subscribe. It supports the channel. You can also leave a like. You can share this tutorial with your friends, or you can just check out other tutorials that I have. So I'll see you in the next lesson.